Hello and welcome to Getting Started with Amazon S3 and Glacier webinar. My name is Guy Farber. I'll be your presenter for today, and with me we also have Brad Karlstad, who is a business development manager from AWS. Brad will be our Q&A moderator today. A little background about myself. I'm responsible for AWS Storage Services. My focus has been helping customers optimize their data storage infrastructure by leveraging AWS's cloud storage services. I help collect customer feedback for S3 and for Glacier product development. And I leverage partners to complement our storage solutions. Prior to AWS, I filled several sales and systems engineering roles with leading data storage and networking manufacturers. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a Q&A panel. Please submit your questions at any time during the webinar. Brad will answer as many as time allows him in the Q&A panel while I'm presenting. Towards the end of the webinar, there will be a live Q&A session, and I will address some questions as well. Lastly, this webinar is being recorded. We will share the recording and the presentation slides via email a few days following the webinar. So let's get started here. Here's what we're going to cover today. We're going to start with an overview of AWS's full suite of storage services. We'll then dive deep into Amazon's main object storage offering, S3, which is designed to provide storage for large-scale web applications. Glacier, which gives you a low-cost, easy to maintain tier for deep archives and long-term backup. And then we'll discuss some options on how to ingest data into the AWS platform. I'll walk you through some of the main use cases, and then we'll wrap up with some Q&A. So just to give you kind of a high-level overview of all of our storage services, data comes in all shapes and sizes with different requirements for performance, cost, and access interface. And AWS provides several services that address those different needs. S3, that we're going to discuss the detail today, is a globally accessible and highly scalable object storage service. Glacier has a similar object architecture, but caters more for deep archives and long-term backup. EBS, or Elastic Block Storage, is a high-performance block storage service dedicated to EC2, our compute service. And EFS, Elastic File System, in a similar way, is a high-performance NFS-based file system dedicated to EC2. And all of these services share a common set of benefits. The first one is economics, which means you never need to put up any upfront investment or commitment. You pay only for what you use, and you don't have to perform any complex or risky capacity planning or modeling, which you need to do on premises in your own data centers. It's easy to use. All of these services were designed to very high levels of availability and durability, and they allow you to reduce time to market by easily provisioning petabytes of capacity in minutes without ever worrying about running out of space or hitting performance bottlenecks. So before we go into detail on S3, let's clearly define what's object storage. It's a system for storing files that, as opposed to a file system, has a flat hierarchy and namespace, and that stores the file metadata along with the file instead of separately in an index. That file plus the associated metadata is then called an object. So that's the difference between an object and a file. The advantages of this approach are enhanced durability, lower cost, and ease of management, and I'll talk through these in a few slides here. So S3 is an object store that's delivered as a managed service by AWS. It's mature, being Amazon's actually first web service that we launched 9 years ago, and it's used today by every imaginable file storage use case. Some of the well-known customers who rely on S3 that you may have heard of include Dropbox, Pinterest, Airbnb, Netflix, and Spotify. The main properties of S3 are first, scale. It automatically and instantly allows you to provision petabytes of data. You never have to worry about capacity management because it's instantly provisioned and you only pay for what you use. It scales performance with capacity fairly linearly. It has very high built-in redundancy. It provides you with 11 nines of durability. And the way we reach that incredibly high number is whenever you upload or put an object into S3, we'll automatically replicate the object across 3 fault isolated data centers. We can then sustain a full facility failure and additional device failures and still have all of your data intact. So this system is bulletproof in terms of availability and durability. It's inexpensive. It costs you 3 cents per gig per month, or a little bit lower if you consume based on tiers, and has no upfront costs or setup costs associated with it. And then finally, you get to leverage AWS's massive investment in security and in our expertise. So some of S3's key features, we're not going to be able to cover all of them today, some of them. The S3 adds a lot of manageability and security features. At a high level, it provides data management tools, ease of use, whether you're a developer through software development kits, SDKs, or even if you're an admin through a graphic management console and a set of CLI tools. It allows you to trigger workflows and send alerts based on events. It provides physical and logical data protection. And from a security standpoint, it provides very fine-grained access controls, very flexible encryption options, and detailed access logging capabilities. Let's talk first about the scale. That's one of the main reasons that our customers love S3. S3 automatically scales to accommodate your capacity and performance needs. Customers no longer have to worry about the underlying storage infrastructure or designing for peaks, which is very error-prone and an expensive practice. You've all been there where you're concerned to ever run out of capacity or performance, so you buy bigger systems ahead of time. Our customers like the maturity and value proposition of the service, which is still growing rapidly. With show you a measure of the growth here in the graph on the slide. Data transfer rates in and out of S3 has grown 102% year over year in Q4 2013. So despite being a very mature service, growing very rapidly. So a little bit more on scalability and ease of use and how this works. So there's no need for you to partition data into volumes to accommodate system limitations or performance considerations. To store object in S3, all you need to do is first designate an AWS region. Within the region, you create a container called a bucket. These are containers for your objects, which are unlimited by size or the number of objects. Really, they're there mostly for administrative purposes. You can use different buckets for different groups in the organizations or different projects and so forth. But they're unlimited. They're the scale of the service, in essence. Once you have the bucket set up, which requires a few clicks on our console, you're ready to store and deliver petabytes of data. It's ready to deliver petabytes. Your application can then perform some basic operations. Put to upload an object, get to read an object, or you can just delete or list objects. So it's pretty simple, 4 types of operations. These objects with the right permissions are then addressable over the internet. So your application basically can access it globally. So you can see that S3 can easily be used for everything from storing media files to application data and backups. But S3 is not just a storage service. It's a web service. So it can be your web server for static content as well, allowing you to completely offload static web serving and run while running dynamic content on EC2. Now you don't have to worry about paying for or maintaining a fleet of web servers for static content and worrying about load balancing, high availability, capacity management, and so forth. So that's just an added benefit and a pretty strong use case for S3. So at this point, I got you thinking that S3 is great, but how much does it cost? So before I dive into that, let's first discuss what you're going to pay for and compare it to traditional storage. With traditional storage, you pay for raw capacity. And the reason it's called raw is because you don't actually get to use all of it. The first type of overhead you need to worry about is data protection. Whether it's RAID or erasure coding, there's an overhead associated with it. And in my example, it takes you down to 800 terabytes of usable storage. Then you need to account for file system and feature overhead, which normally gets you down to around 600 terabytes in my example. But even though 600 terabytes is not something that you can use, because if you've managed storage at scale, you know that you have to leave a buffer for operational reserve and some free space, whether it's for performance or free capacity purposes. So in my example, we're left with 400 terabytes that you can actually use to store your application data. And that's even before taking into account the need to do disaster recovery and create additional replicas for business continuity. With S3, on the other hand, you only pay for what you use when you use it. So if at some point in time you have 400 terabytes, you will pay for those 400 terabytes, despite the fact that we have this massive protection scheme for you across 3 different fault-isolated facilities. And this causes a dramatic difference both from a CapEx and an OpEx standpoint. So S3 is priced using a measure called gigabytes per month. We actually track it hourly, but we give you a bill on a monthly basis. We just average the usage and then charge you for that. We have different prices in different regions, and we charge lower where our costs are lower, and it's available out of 11 regions today. In our core regions, prices are 3 cents and below, as you can see under standard storage in the screen capture I added to this slide. Compare that to the cost of purchasing storage systems, maintaining replicas, and the associated capacity buffers required, administrative effort, and data centers and facility costs. In addition to that, I'd like you to look at another interesting issue here. AWS is focused on continuously taking cost out of our operation and giving it to our customers in the form of cost savings. So S3 has a strong record of price reductions with 8 price cuts already since we launched the service 9 years ago. And last year, in April 2014, we cut it by an average of 51%. So that's pretty dramatic. And the reason I'm telling you all of this is because when you do 3, 4, or 5-year TCO calculations, which is the normal depreciation cycle for hardware, you need to take into account a measure of S3 cost reduction, because we're going to be diligent around cutting our pricing over the next few years. We understand that some of these calculations around TCO can be pretty complicated, so we have a dedicated team of TCO experts that is ready to help you model costs. So please contact your account team if you need our help, if you want to engage us. So while S3 is inexpensive, or rather I should say S3 standard is inexpensive, we also give you the flexibility of using a less durable storage tier for a lower cost called reduced redundancy storage or reduced redundancy option. That's a good choice for reproducible or temporary data sets, and it has 4 nines of durability versus the 11 nines of S3 standard. But what you get out of that is you get to save roughly 20% on average on our public pricing. And if I go back to the previous slide, you can see that on our public pricing page, you have a reduced redundancy storage pricing column, and you can check that. You can check the differences over there. So our customers told us that they love S3's durability and the ease of use, but they have data sets that are very infrequently used, and usually kept around for compliance or for future purposes. These do not require real-time access, and that's why we introduced Glacier a few years ago. So Glacier is an object store like S3. It shares the same ease of provisioning and extreme durability, but at a much lower price of a cent per gig per month. So, close to a third. And I've done the math for you. That's $123 per terabyte per year. That's a figure that's a little bit easier to wrap your head around. Because this service was designed for cold data sets, as the name Glacier implies, the service doesn't retrieve objects in real time. That's the trade-off here, but has a latency of 3 to 5 hours. So from the moment you request an object to the moment you can actually download it, it's going to be 3 to 5 hours. This is, somewhat similar to a tape vaulting paradigm, but still much faster. You should also be aware that we give you 5% of your overall capacity as a free retrieval tier. So for example, if you have 100 terabytes stored on Glacier, you can retrieve up to 5 terabytes monthly for free. Above that, we're going to charge you retrieval fees. So if it's a good use case, most deep archives, you're not going to retrieve more than a percent per month. If you have a use case that's, my rule of thumb is 10% per month or higher than that, it's probably not a good use case for Glacier, and you should be using S3. So to summarize this, Glacier gives you a great opportunity to stop managing disk and tape and virtual library infrastructure and avoid the associated cost and durability challenges that they present, and move to putting your deep archives and long-term backups into AWS. There's 3 ways to ingest data into Glacier. There's a direct Glacier API and SDKs, which should be used for building archive applications. So this is mostly for developers. They want to develop applications that vault into Glacier. And what you need to know when you use Glacier directly is you need to manage your own metadata index separately, as opposed to S3, which does manage your metadata for you. A simpler way, perhaps, of using Glacier is to use S3 lifecycle integration. Here, you can upload objects into S3 and define a policy that after a certain period of time, which could be even 0 days or could be years, it'll automatically transition the objects based on their age and their names into Glacier automatically for you and maintain the metadata in S3. And the third way is if you have off-the-shelf backup and archive software and you want to integrate them into S3 and Glacier, and S3 and Glacier have API interfaces over HTTP. How am I going to connect that if they don't provide native support? Well, we have a host of third-party tools and gateways that are basically presenting an IT-friendly interface like iSCSI or NFS to your backup application, and then translating that and transferring it for persistence in S3 and in Glacier. And we'll talk a little bit about that in a few slides. So just to kind of summarize all the options here, we've got S3 standard as the premium offering. It's reliable, durable, and it's used for primary storage. It's real time. You use S3 reduced redundancy when you can easily reproduce the content or its temporary nature, and you get a discount off of that. And you can use Glacier to tier off objects off of S3 that you're not going to be frequently retrieving or accessing, and you're going to pay almost a third the cost of S3 standard. Let me give you an example of how an S3 lifecycle policy works. So an S3 lifecycle policy can address an object by name or the way the name begins, something we call a prefix. So I'm going to look here at all the objects that start with logs /. So even though an object store is a flat namespace, I can sort of create virtual directories by prefixing the object names with a certain word like logs. So I'm going to take all of my logs and I'm going to transition them to Glacier 30 days after creation, because at that time I don't need to analyze them frequently anymore. I just want to keep them around in case I want to run some new algorithm against them or I want to check into something. After a year, I also have the option, and a year is just an example here, I can do it whenever I want. I can also automatically expire or delete these objects. This is really useful if you know that after a certain period of time, you're not going to need this data anymore, or even more importantly, if you're obligated to delete that data for compliance purposes after a certain period of time. Now you can just automate it through these policies. Let's dive into some more advanced S3 features. S3 versioning is a very important feature. It allows you, it augments S3's extreme durability and high availability with a measure of logical data protection. Once turned on, S3 will keep a version of all changed objects to protect you from human error or data corruption. So basically a logical level of data protection. Whenever you rewrite an object or override an object, it'll keep the previous object and give it a version ID. In case you need to go back, you can easily go and read the versioned older object or copy it over the new one, basically revert back. And you can turn on this functionality very easily at a bucket level by checking a box on our console, and then you're enabled for data protection. One of the main reasons that some customers were hesitant to adopt versioning in the past was that they were concerned about being able to limit the number and capacity associated with versions. Well, I don't want to keep all of the versions ever since I created the object. So with the introduction of lifecycle support for versioning last year, we solved that issue. And now you can limit how many versions S3 keeps by leveraging expiration policies. And what you can also do, which is interesting, you can transition some or all of your versions into Glacier, and then your versions will cost you less, but you still get to keep them around. So this is pretty powerful stuff. Now, even though S3 provides 11 nines of durability out of a single region, out of the box, basically as soon as you create a bucket, some of our customers were asking us to automate replication of objects between regions. So in addition to the replication we do within a region, to help them achieve compliance objectives, to distribute the copy to achieve lower latency, kind of get closer to their users in a different region, and also to enhance access security. S3 users can now configure automatic replication of newly created objects with a few clicks of their AWS console. And this is supported between any two regions at a bucket or at a key name prefix granularity. So you don't have to replicate the whole bucket. You can just replicate a prefix. In the first stage of this release, we only support one-to-one replication, and we also require versioning because we want to avoid replicating hard deletes. It's a security measure. What's really interesting about this is many customers told us since we launched the feature a month or so ago is that they actually plan to use this feature to enhance security because it allows you to replicate data between buckets that have complete separate owners. So I can have two separate copies in two areas of the country that are owned by two separate administrative credentials. It's pretty powerful stuff. Back at reInvent, our annual customer event, we announced S3 notifications on puts. What that allows you to do is as soon as your application uploads an object into S3, for example, a high-res photo, S3 will fire off a notification that goes to either one of three AWS services. The simple notification service for notifications, SQS, or simple queuing service, which then allows you to pick up the message by a compute worker and process it, or Lambda, our event-based computing service, which allows you to run simple computing jobs without provisioning any infrastructure and paying only for what you use. So you can leverage this for some powerful things. Imagine you're developing an application that has user-generated images, like an online store, dating application, or photo management platform. You can use S3 event notifications with Lambda so that when a user uploads the photo, it'll automatically kick off Lambda functions to process a thumbnail and resize versions for different mobile device formats instantly and without provisioning any infrastructure. and then finally place all these different versions and different formats of these photos back into the S3 bucket in the proper location to be served instantly to that user or other users. This just makes it a lot easier to create multiple versions of a photo on demand. Another highly requested feature we recently released, as a matter of fact, we released it last week, is virtual private endpoints for S3 or VPCE. That's a catchy acronym. Before VPCE, for customers using our compute services, they were accessing S3 as an external internet service. So with this approach, it had the disadvantage of requiring customers to configure and manage internet gateways, which allow you to access the internet from within the EC2 network. And if you were using private IP addresses, you also had to configure, scale, and provide high availability for NAT instances that translate those IPs. With VPCE, you no longer have any of this complexity. Internet gateways and NAT instances are no longer necessary for you to access S3. It also improves security by guaranteeing that access to S3 from EC2 in the same AWS region will be over the internal Amazon network, will not traverse the internet. So to use this, you need to run EC2 in our virtual private cloud, VPC, a service that allows you to have your own isolated network within EC2. I think the majority of customers use VPC today in EC2. And then create what we call a private S3 endpoint for that specific VPC. So again, this is much easier to configure and more secure, and you can configure these endpoints in a matter of minutes. You can also create multiple endpoints within a single VPC, each with a different S3 security access policy for fine-grained control per application or project. Finally, this is more than just a feature for S3. It's an infrastructure innovation that will allow us to add additional private service endpoints in the future. S3 was just the most highly requested one by customers, so we're starting there. What about data encryption options? The S3 provides a lot of flexibility when it comes to securing your data. And there are two main approaches here. One is client side and the other one is server side. With client side, you have the highest degree of control as a customer. Your app can use our SDKs, which contain an encryption client. So you effectively are responsible for both the encryption and the key management. You manage your own keys. We make it a little bit easier by giving you an encryption client, but you do your own encryption. If you prefer that AWS encrypts the data for you, the simplest way to do it is with SSE or server-side encryption, which also hands over key management to S3. Basically, S3 encrypts every object with a unique key and encrypts those with a master key that gets regularly rotated by the service itself. You basically trust us, and whenever you upload an object, you tell us to encrypt it ourselves. With server-side encryption with customer keys, you can have more control by managing your own keys. And what you do is whenever you put an object to S3, you give us an encryption key, we encrypt the key with your key, and then we get rid of it. And you also need to provide us a key when you get the object so we can decrypt it for you. We do the encryption, you provide the key management. And then finally, and I think the most intriguing option is you can use Amazon Key Management Service, KMS, which we launched at reInvent, which allows you to centrally and securely manage master encryption keys and also shred them, rotate them, and audit their usage, and it tightly integrates with S3. This is a pretty powerful option. If you want more details on all of these, a real deep dive, you can go to our YouTube channel and look for the encryption and key management presentation, which was delivered at the San Francisco Summit recently. Okay, so we know how to store object data, but how do I get data into the platform? You can securely upload and download your data to Amazon S3 via the TLS encrypted endpoints using HTTPS. Some customers wish to entirely avoid their data traversing the internet. For them, we have what we call the AWS Direct Connect service, which makes it easy to establish a dedicated network connection from your premises to AWS. Using AWS Direct Connect, you can establish private connectivity between AWS and your data center, office, or co-location environment, which in many cases can reduce your networking cost as well, and increase bandwidth throughput and provide a more consistent network experience than internet-based connections. And we offer fractional gigi, and 10 gigi connections with directly into AWS with Direct Connect. AWS Import-Export accelerates moving large amounts of data into and out of AWS using portable storage devices for transport, basically disk drives. And AWS transfers your data directly onto and off of storage devices using Amazon's high-speed internal network and bypassing the internet. And finally, on the right-hand side, you can see we have several partners that specialize in accelerating and managing the data transfer of large data sets, like, for example, what you see in the media entertainment or genomic sequencing industry when you need to move really large files, and making sure you make the most of your available bandwidth. So let's talk a little bit about the use cases, some of the most common use cases for S3. You can use it to build a web scale application and not have to worry about underlying storage capacity and performance. And you can also offload, as we've seen, static web pages. You can deliver media such as video, music, photos through a CDN with S3 providing the origin store. When you use Amazon's big data analytics services such as Elastic MapReduce, EMR, and Redshift, our data warehouse service, you can use S3 as a durable and inexpensive storage for staging and persisting the data before and after processing runs. And then finally, you can leverage S3's economics, durability, and ease of management to use S3 and Glacier as a backup and archive target. Let me give you a little bit, some examples and a little bit more information on that. One customer that provides a great example of running a SaaS application while leveraging S3 for storage is Druva InSync. Druva InSync, excuse me, is an enterprise endpoint protection solution that runs on EC2. You can kind of see that in the diagram. They run it in 2 AWS regions for redundancy, so a client can connect to either region. The endpoint clients then connect to the service and store their data durably in S3, and the file metadata is stored on DynamoDB, our high-performance NoSQL database, which then enables them to do fast searches across all of the user's backups and also run value-added functions like e-discovery. And you can find more details about their use case in the URL in the bottom. So with content distribution, you want to get the content as close to the user as possible to deliver a great experience by lowering the latency, right? We've all seen that when we watch video on demand, consume music and so forth, and load photos. This is effectively achieved by content distribution networks, and we have our own. It's called Amazon CloudFront, who cache content at the edge, and we call these edges edge locations. S3's superior durability and infinite scale make it an optimal origin store for one or multiple CDNs. So instead of, for example, if you use multiple CDNs, you need to make copies into all of their origin storage. Instead of that, you can serve all of them with one origin store using an S3 bucket. CloudFront is also tightly integrated with S3, and what makes CloudFront even more compelling with S3 is that data transfer into CloudFront from S3 is now free. A little bit on CloudFront. It provides a low-cost means for global distribution of your content with a pay-as-you-go pricing, pretty much same as most of our services. It can be used for full site delivery, dynamic content, or just static content resource delivery, depending on your needs. and it currently has 52 edge locations globally. You can kind of see the distribution in the map on the slide. And we keep adding additional ones based on feedback from our customers. So expect this to continue to grow and scale. A customer that makes great use of S3 and Glacier for content distribution is SoundCloud, which are based in Germany. They're the leading social platform for artists, allowing them to upload songs and sounds and then deliver and share it across multiple devices and social networks. You know, I follow sports pretty closely, and I now see pretty much almost every basketball interview also being delivered through SoundCloud and embedded in websites. But the way these guys use S3 and Glacier is they transcode on S3 for real-time delivery into all these social networks and devices. And then once they're done transcoding, they move the original to Glacier to benefit from reduced capacity fees, effectively a third the cost. Big data analytics is a rapidly growing use case for both S3 and Glacier. Companies are collecting enormous amounts of data, whether it's consumer behavior or for operational data from servers and network devices. And it's a lot easier than before. It's a lot more cost effective to leverage AWS's powerful big data services to do things like analyze what consumers are looking to buy and presenting them with relevant products as they explore the web, as you can see in my illustration here. S3 can be used for staging and persistently storing big data. In this use case, customers use S3 both as a staging area to load data into EMR, our managed Hadoop service, and persist it between processing phases. You can also use it to load data very easily into Redshift, our managed data warehouse, and then perform operations like interactive querying of data. So just think of S3 and the durability it provides as sort of your data lake, where you can have multiple processing service, get data from that data lake, process it, and then put it back in place. And the benefit it provides is the durability and the proximity to all of these processing services. Netflix uses S3 to store data for their cloud-based massive data warehouse, which allows them to process billions of events. You can read a little bit more on that in their blog. And these events are coming from the different TVs, computers, and mobile devices that they support, that we all use as users of the platform to view movies and TV shows. And Netflix uses S3 with multiple Hadoop clusters. They use these different Hadoop clusters for different workloads, but all of them can access the same data set, which is very powerful for them. Their implementation benefit from S3 is durability. So that's a key reason why they use it. The ability to infinitely scale storage separately from compute. So they scale compute using EMR, using Elastic MapReduce, and then S3, they just rely on the infinite capacity. And then finally, they like leveraging our versioning capabilities to protect themselves from an accidental delete or overwrite by a developer. And then let's move on to backup and archive. You know, by leveraging S3 and Glacier as a backup and archive target, you can stop worrying about provisioning, managing, and sizing disk and tape-based storage systems and replicating their data or vaulting it off-site for DR purposes. You can leverage S3 and Glacier in a tiered configuration to either write your own backup and archive routines to put warm data into S3 and cold into Glacier, or leverage backup and archive tools that integrate with our services. So I'll give you a little bit more information in the next few slides. So a lot of customers said, you know, this is great that you have S3 and Glacier and we can write our own applications to store data, but how do we move backup data sets and archives from our own data centers using the existing backup and archive tools that we have? This is where the AWS Storage Gateway comes into play. You can download the gateway as a virtual machine from our website, and you can also trial it for free for 60 days. You then download it into a VMware ESX or a Microsoft Hyper-V host, and it'll then present an iSCSI interface, which you can then mount into your backup server and start backing up data into the gateway. Once you back up data into the gateway, it'll cache and buffer some of it. It'll then encrypt the data and gradually transfer it into a storage gateway endpoint on AWS, which will then persist the data in S3, benefiting from the high level of durability. And the same, you traverse the same path when you need to restore data. It's very inexpensive. We charge you $125 per month per gateway, and then you also pay the associated S3 storage fees. So it's just a very easy to use and inexpensive solution to integrate with existing backup applications. If you prefer to use more of a tape paradigm, because today you're backing up the tape or the virtual tape libraries, you can also run the gateway in VTL mode, in virtual tape library mode. Here, you can point your backup application at the gateway and you're backing up tapes. Those tapes can either stay within the virtual tape drives in the VTL, and which the gateway then persists into S3. And if you ever eject those tapes and put them on the virtual shelf, it means it'll get tiered off to Glacier and you'll start paying Glacier fees instead of S3. So we're sort of applying a tiered virtual tape library paradigm and a vaulting paradigm, but all of that runs on the different AWS services. It's the same storage gateway, you just choose a different mode when you initially install it. Same pricing as well. We also have a really rich ecosystem of technology partners here. You can use some backup and archive software that natively support S3 as a target. So there's no need with Commvault and Symantec Net Backup and Cetera to use a gateway at all. You can just back up directly into S3 and Glacier, and they define them as cloud targets. But if you want to use existing backup applications and you prefer to use a partner technology product, you can use gateway products from companies such as NetApp and Quantum and Avir, which basically bridge the two interfaces. Locally, they'll provide an IT-friendly interface like NFS or iSCSI, and then on the cloud side, they'll talk to us using native APIs, and it also provides some value-added services in between. So here I have an example of a customer that uses NetApp SteelStore to back up data into S3 and into Amazon Glacier. So this customer, which is Spot Trading, they're a proprietary financial trading company, is using Glacier and NetApp SteelStore to significantly simplify their backup process. And you can see some of the benefits on the right-hand side of the slide. They've been able to cut costs and achieve a 2-year ROI when you take into account the cost of both the gateway and Glacier, the service costs. Improve the restore times from days to hours if you retrieve data all the way from Glacier, or minutes, some recent data that's still sitting on the appliance. You can kind of see the workflow in a simple diagram I have below. The backup software points at the SteelStore device, which can either be a physical device or virtual machine running on a virtualized server, which presents a CIFS, Windows share target to your backup application. Your backup application then starts backing up to SteelStore. SteelStore accepts the data, deduplicates it, so it provides data reduction, compresses it, and encrypts it, and also caches it locally with as much capacity that it has. And then it persists it into Glacier. So recent backups can then be pulled locally from the gateway cache for fast restore. Let's say you accidentally dropped an Oracle database table. You want to pull it real quick. It still sits on the appliance. While longer term backups, like a user found that they accidentally deleted an Excel spreadsheet 2 weeks ago, that's stored durably in Glacier and can be retrieved within a few hours. So what's next after we've gone through this introduction? You can check out the Getting Started guides on our website. They have a lot of links and pointers into our documentation. You can evaluate our public pricing, the cost of complete configuration, not just S3, full suite of services, using our simple monthly pricing calculator. And one of my favorite resources is the AWS YouTube channel, where you can find recorded sessions organized by event and topics. So most of our major events get recorded, and then we put it over there, like reInvent and the recent San Francisco Summit. And you can view deep dives on specific services, solutions, and industries, as well as a variety of customer use cases. So at this point, I want to thank you for your time today. I hope you found the content useful, and we're